All right, so I got you guys a second example on here, and the reason why is you guys always say I do the easy problems, but honestly, this one, it looks crazy. We got these e to the x's, kind of looks scary, but it's actually easier than the others. But I looked through the other problems, and I was thinking, like, this might be one that questions might pop up on, so let's just go ahead and go through it. So we want to figure out what f of 0 is, so we need to start with f of x. So f of x is going to be the antiderivative of f prime. And f of prime, I'm just going to go ahead and put that in there as 12e to the x dx. So we're doing the antiderivative of f prime to get our f. So that antiderivative is really simple. It's just 12e to the x and then plus c. So once again, this right here is our general solution because we do not know what c is. But we are given this initial condition. So right here, we're given this initial condition of f of 4 equals negative 16 plus 12e to the fourth. So I'm going to go ahead and plug in and 4 into our x. And realize that f of 4 is negative 16 plus 12e to the fourth. So I'm going to substitute that in for f of 4. So we'll have negative 16 plus 12e to the 4 equals 12e to the 4 plus c. So I'm going to go ahead and solve for c by subtracting the 12e to the fourth to the other side. And it works out quite nicely because they cancel out, and you're left with c equals negative 16. So now I'm going to take that value of c, negative 16, substitute it in for our constant of integration right here, and we will have the particular solution of f is 12e to the x minus 16. So once again, this part is the particular solution. So to answer the question here, they're asking us what is f of 0. So I'm going to go ahead and find f of 0 now that we have our particular solution. So f of 0 is going to be 12e to the 0 minus 16. And remember that e to the 0 is just 1. Anything to the 0 is 1. So we have 12 times 1 minus 16. Simplify that with a little bit of PEMDAS, and you got yourself f of 0 is negative 4.